We have another question which says calculate the volume and weight of air required for complete combustion of coal, equivalent to 4 kilograms, with the following compositions. Carbon is 85%, hydrogen is 10, that makes 95%, then oxygen is 5%, so that makes it 100%. You should always do the calculation, add these totals to see if it adds to 100. And now to solve this problem, always we begin with chemical reaction. Always begin with chemical equations. So for carbon, we have carbon plus oxygen. It is complete combustion, so it gives carbon dioxide. So this is telling us composition, calculate the volume and weight of air required. So what we are going to do is to first get this by weight. Okay, we are going to use the kilograms or the analysis by mass, and then we can later on convert it into volume. But you can also look at it in a way that you can first use the volume and go to mass later on. But since we are given the kilograms of coal, then we are going to start by kilograms, analysis by mass. So this is 12 kilograms. We have 32 kilograms, giving you 44 kilograms. So oxygen required here would always be 32 out of 12. Okay, then we multiply by the amount of carbon present in the fuel, that is 0.85. So that's how we can always do those such problems, even without wasting a lot of time. 32 divided by 12, we multiply by 0.85, and this is 2.267 kilograms. Then I will also, this is of oxygen. Then I will need to look at combustion of hydrogen. Hydrogen also burns, so combustion of hydrogen. So get hydrogen plus oxygen, we get water, and let's take a half there, so this will be 2 kilograms, 16 kilograms, giving you 18 kilograms. So oxygen required. Oxygen required will be this 16 divided by that, then times the amount of hydrogen present in the fuel, which will be 0.1. So you will have 16 divided by 2 times 0.1. So obviously this becomes 0.8 kilograms. So mass of oxygen, will be 0.8 plus 2.27 plus 0.8, I have 3.067 kilograms. So net oxygen will be oxygen needed minus oxygen available. Because in fuel, you can see there is some oxygen present, so which is 0.05. So what we do, this is going to be 3.067 minus 0.05. Because 5 divided by 100 is 0.05. So if we subtract it from 3.067, then we have 3.017 kilograms. So what happens? We need the mass of air. So if we know the mass of oxygen, then we can relate it with the mass of air and then be able to determine how much of air was required in order to supply 3.016 kilograms of oxygen. So what happens? What we are going to do, we are going to say 23 kilograms of oxygen is present in 100 kilograms of air. So what about 3.017 kilograms of oxygen will be present in 100 divided by 23 times 3.017 kilograms. So multiply by 100 divided by 23. So I will have the mass of air as 13.11 kilograms. If I want volume of air, I know that 29 kilograms of air occupy 22.4 cubic meters. So this is by volume. So what about the 13.117 kilograms? It will occupy 22.4 divided by 29 times 3, 13.117. So I multiply this value by 22.4 divided by 29. So the volume of air that will be required, will be 10.132 cubic meters. But this is okay. Let me see what we have here. What we have here is per 1 kilogram. So if we wanted for the 4 kilograms of that core, then we will just multiply by that value, and therefore for 4 kilograms of core, then mass of air will obviously be the 4 times this 13.117, and this is equal to 4 times 13.117. This is 52 52.468 kilograms of air. So what about the volume? The volume it occupies, obviously will also equal to 4 times what we have up there, 10.132. 10.132. So 4 times 10.132 would give you 40.528. So the volume of air for 4 kilogram of coal complete combustion will require 40.528 cubic meters. So members, that's how we can attempt and answer this problem. I want to thank you and entertain any questions, if any.